in this exercise, we're going to get questions where they may ask, if you have a look at exercise 7 down here, it says find the global maximum and minimum of the function. So this is the key word, global. So to be able to answer this, you need to understand what the difference between a global maximum and a local maximum. So with a global maximum or a global minimum, it is the absolute maximum that graph takes on. Okay, so all the other, when you've got another maximum, which is right here, okay, we call those local. So you need to know the difference between a global and a local maximum. Now, if you look at the minimum, for this particular graph down here, this obviously is going to go all the way down to minus infinity. So that's why we say it's a global minimum. Okay. So sometimes they may ask you for the global maximum. So if you look at this graph here, and assuming that this is 1, 2, 3, 4 going across, so this value here is about here, and it looks like it's about 3.7. Okay, and then the global minimum is minus infinity. All right, so there are a couple of other points that you need to know, and it's this sentence here. There is only one global maximum and one global minimum, but there can be many local. So the key here is knowing the difference between a global or a local maximum and minimum. So let's have a go at a question. So we've got here, find the global maximum and minimum of the function. So here what we've got is like a cubic type curve because the highest power is to the 3. So obviously if we go to draw this graph, we've got to go and find the first and second derivative. But this is pretty important as well, okay, because we've got to find out where does the graph go when x equals a half and when x equals 5. So our steps are find the first derivative, and that's pretty easy. 3x squared minus 12x plus 9. Then we find the second derivative. Okay, so that's going to be 6x minus 12. Okay, and then we say stationary values occur when f dash x equals 0. So if we have a look here, we'll have 3x squared minus 12x plus 9 equals 0. So that's the quadratic we need to solve. So divide everything by 3. X squared minus 4x plus 3 equals 0. And then you say to yourself, okay, how do I solve a quadratic? The first way is to try and do it by factorising. And we're lucky in this case because if we factorise this, we need two numbers that multiply to give positive 3 and add to give minus 4. And it looks like those two numbers are minus 1 and minus 3. Okay, so what we now need to do, we actually now need to find out whether they are a maximum or minimum. Oh, sorry, we've got to solve this. So we've got stationary values occur when that equals 0. So that means they occur, therefore occur when x equals 1 or x equals 3. So let's find out whether they are a maximum or a minimum. So if we go when x equals 1, okay, so let's find out what the graph is first. Oh, sorry, whether it's a max or minimum. Okay, so we put it into this one, so we get 6 lots of 1 minus 12, which is negative 6. Okay, we better find out what the graph is as well. So if I put it into the actual function, which is up here, I get 1 cubed minus 6 lots of 1 squared plus 9 lots of 1 minus 4. So I get 1 minus 6 plus 9 minus 4. And what's that? Minus 5 plus 9 is 4. 4 minus 4 is 0. Okay, so what does that tell us? What does the second derivative tell us? It tells us that because it's less than 0, okay, so it's going to be concave down, which means it's going to be, so we say here, since f dash dash x is less than 0, therefore it's a maximum turning point. Okay, so what we do know, so what that actually means is that therefore, so what's the coordinate? 1, 0, so therefore 1, 0 is a maximum turning point. So we've done that one, so now what we've got to do is do exactly the same process for when x equals 3. Okay, so let's go through and go, when x equals 3, what does the second derivative equal? It equals, remember, putting it into this one, 6 lots of 3 minus 12, which is 18 minus 12, which is 6. Okay, so the fact that that is positive, okay, means that it's concave up, which means this has to be a minimum turning point. Okay, therefore minimum. But let's go and find out what the actual point is. So we need to put it into the function to find the coordinate. So we put it into this one up here. So we get 3 cubed minus 6 lots of 3 squared plus 9 lots of 3 minus 4. So I'll just move this down a little bit. Why won't it move? Oh, I don't know. Which is, what's that? 27 minus 6 lots of 9, which is 54, plus 27 minus 4. So that's 54 minus 54, 0 minus 4, which is negative 4. All right, so what has that actually told us? It's actually told us, okay, what do we got here? Oh, I don't know what's happening here. Anyway, so that's actually told us that the coordinate 3 minus 4, so therefore 3 minus 4, so it's a minimum, is a minimum turning point. All right, so we haven't found out yet what is a what's a global maximum or a global minimum. So remember this curve. Okay, sorry, I'm just trying to move. I don't know what's going on here. So I'll try and do. Okay, so what we need to do, remember the domain is very, very important. So we find out what the graph's happening when x equals a half. So to understand what we're doing, it's probably worthwhile just starting to put this into a little bit of a graph, just a sketch, because it does help you understand what's happening. So that's your y-axis, your x-axis. So what are our 2 points? We've got 1, 0, so across 1, up 0. All right, now what is that? That's a maximum turning point. Okay, so we know that it's going to cut the y-axis when x equals 0, so when x equals minus 4, so that's minus 4. But remember, this graph doesn't exist, it only exists from x equals a half, okay, over to x equals 5. So what's happening at these 2 values? So we say when x equals a half, okay, what's happening to the function? So what we want to do is put it into the actual equation of the graph. So this becomes a half cubed minus 6 lots of a half squared plus 9 lots of a half. Okay, and what have we got to do on the end here? We've got a minus 4. So what's that? That's 1/8 minus 6 lots of a quarter plus 9 over 2 minus 4 Alright, so you can either just keep working that out in your head, or you can go and get your calculator, okay, and you should get minus 7 over 8. So what that's telling me is that that graph only stops there. So I'm just going to rub this graph off a little bit. Okay. Make it a little bit bigger. Alright, so here's my y-axis. Here's my x-axis. So we know that the graph, okay, at 1/2 minus 7/8, so that's probably, if we say here, so that's minus 7 over 8, and that's a half. We know that 1/0 is a maximum, okay. So what's happening at the other end when x equals 5? So when x equals 5, okay, we get function 5. So put that into your graph. So that's 5 cubed minus 6 lots of 5 squared plus 9 lots of 5, okay, minus 4. Now when you put that into your calculator, I'm hoping you get 16. So we know when x equals 5, somewhere up here, that you're going to get 16. 5, 16. So we know that that graph's going to go there. So we haven't put the minimum in yet. So we know that roughly here's 3. So this might go down to minus 4. So it's almost like this graph comes up here. Okay, so that is the graph between this domain. So basically what it means is that the graph is only between that domain there. So let's have a think about what the absolute minimum of that graph. It is down here. Okay, so what was that value? That was when x equals 3, so that's minus 4. Okay, so this is the global minimum. Okay, is 3 minus 4, and this is the global maximum. Okay, so the global minimum is actually only one value, so not the coordinate. We say the global minimum is y equals minus 4, and what's the global maximum? Global maximum is this value up here, which is 16, so y equals 16. So that's enough now to get you through exercise 3F. Good luck with that, and if you need any help, let me know.